Welcome to KSG's presentation of lattice energy, chemical kinetics, and linear regression. Make sure you have a scientific calculator. Question 1. Which one has the higher lattice energy and why? Sodium fluoride or magnesium oxide? Solution. The charges of sodium fluoride are sodium equals +1, fluorine equals -1. In magnesium oxide, the charges are, magnesium equals +2, oxygen equals -2. Two main factors contribute to the lattice energy of an ionic solid, the charge on the ions, and the radius, or size, of the ions. The effect of those factors is, as the charge of the ions increases, the lattice energy increases too. When we compare the energies of MgO to NaF, the lattice energy of MgO is 4 times that of NaF as shown. Therefore, MgO has higher lattice energy than NaF. Question 2. Which one has higher lattice energy, sodium fluoride, or potassium chloride? Solution. As the size of the ions increases, the lattice energy decreases. F has smaller atomic size than Cl. Additionally, Na is smaller than K. Hence, NaF has higher lattice energy than KCl. Question 3. A second-order reaction with a rate constant of 0.413 cubic decimeter per mole per second. If the initial concentration of the reactant is 5.25 times 10 to the power -3 mole per cubic decimeter, how long will it take for initial concentration to reduce to half its initial concentration? Solution. The above question is about finding the half-life of the second-order, integrated rate law. The half-life equation is T half equals 1 divided by rate constant times initial concentration of reactant equals 461 seconds. Question 4. The dipole moment of hydrochloric acid, HCl, is 1.11 dBi and the distance between the ions is 127 picometers. What is the percent ionic character? Solution. Measured dipole moment, mu equals 1.11 dBi. We know that 1 dBi equals 3.3356 times 10 to the power -30 coulomb-meter. We have to convert dipole moment to coulomb-meter. Measured dipole moment, mu equals 3.703 times 10 to the power -30 coulomb-meter. Calculated dipole moment, mu equals q times r equals 2.035 times 10 to the power -29 coulomb-meter. Percent ionic character equals measured dipole moment over calculated dipole moment, times 100 equals 18.2%. Question 5. For the decomposition of dinitrogen pentoxide, the following information was collected as shown in the table below. Question 5 continued. Find the order of reaction with respect to the reactant, use linear regression. Solution. All we know is that the reaction could be anything from 0 to second order. So we have to treat the data to statistical analysis, as shown. Under integrated rate law, we have to find the values for the y-axis. A plot of concentration versus time is zero-order reaction, that of ln of concentration against time, is first order. Finally, a plot of 1 over concentration versus time, is second order. Pause the video, find the different concentrations. How to use scientific calculators in linear regression. All scientific calculators fall under any of the three listed calculators. When you use a calculator, the equation of the straight line is y equals bx plus a, where b is the gradient, y is the concentration, x is the time, and a is the y-intercept. Both the gradient b and r values for zero and first-order kinetics are negative because they have negative gradients. The biggest value of r falls under first-order kinetics, so the reaction is first-order with respect to dinitrogen pentoxide. Treat all r values as absolute values. B. What is the rate law for the reaction? Solution. We know the reaction is first order with respect to dinitrogen pentoxide. Rate equals K times concentration of dinitrogen pentoxide. See what is the integrated rate law for the reaction? Solution. Remember the reaction is first order with respect to N2O5. D. How much reactant remains 4,500 seconds after the start of the reaction? Solution. The equation of a straight line is y equals bx plus a, where a equals 1.598, b equals minus 6.887 times 10 to the power minus 4. Y equals minus 1.501. Y equals natural log of concentration of N2O5. We have to raise the value of y to the Euler's constant, E. And there is the solution.